Let's take our example from the last video, and we've determined the total capacitance across points A and B is 3/5 C, C being the value of each of the capacitors, C1, C2, C3, and C4. And now we want to find the charge on each capacitor and the potential difference across each capacitor. Let's start with defining our charge, QT, is going to equal to CT times V. And substituting in for total capacitance, that's just 3/5 C times V. Now, we stated that the same amount of charge, Q4, is going to be the same as the total charge that we had from the potential between points A and B. So that means that QT equals Q4. So I have 3/5 C times V is equal to C4 times V4, but C4 is just equal to C, so the two C's will cancel out, and I get V4 is equal to 3/5 V. Now I have to figure out how much potential is going to be across C1, C2, and C3. Well, I know that V3 is going to have to equal, I'll put here, let's see, we'll put V4 here, we'll say V3, we have Q3, we'll put here just so we're clear. We know that the potential across capacitor C3 has to equal the sum of the potentials across capacitor C1 and C2. If not, we would have things moving around, and then we're in equilibrium here. But that's also going to be equal to V minus V4. And so I have equal to V minus 3/5 V is equal to 2/5 V. So that's what V3 is equal to. And V1 and V2 are going to equal, because they have the same capacitance, okay, so that means that since they're equal and they add up to V3, V1 is going to be 1/5 times V. V2 is going to equal 1/5 times V. V3, we'll just rewrite that, that's 2/5 V. And V4 is equal to 3/5 V. And now I can write for Q1 is equal to C1 V1, and that's just going to be 1/5 C times V. Q2 is equal to C2 V2, and that's going to be 1/5 C times V. Q3 is going to equal C3 times V3, and that's going to be 2/5 C times V. Q4 will equal C4 times V4, and that's just equal to 3/5 C times V. And we had QT is equal to, we calculated that here already, and that's going to be 3/5 C times V. And of course, we have the V there, which is equal to V. So this gives us all of the voltages across each capacitor, the potentials, and also the charges that are on the plates of each of the capacitors.